Good morning to one and all present here. I am Sadish Kumar, working as assistant professor at KS Rangasamy College of Technology, and I am handling the subject antenna and microwave engineering. Today we discuss about smart antennas. A smart antenna is an antenna system using an array of antenna elements, which combined with the digital signal processing to adaptively change its radiation pattern to improve signal reception, minimize interference, and increase capacity. By employing techniques like beamforming and direction of arrival estimation, smart antennas can focus signal towards desired users and away from interfering sources. It's significantly enhancing the performance of wireless communication system in complex environments. So why we are using smart antennas? To improve the wireless communication systems by providing increasing increased range, signal quality and data rates through technologies like beamforming and adaptive signal processing. They offer significant benefits such as reduced interference, enhanced spectral and energy efficiency, and greater capacity to handle multiple users simultaneously. The aim of smart antenna is to maximize the antenna gain in a desired direction where more number of users in the particular location we are improving the gain at the particular direction to minimize the gain of directions of inferior interferers. So types of smart antennas are two types: switched beam antenna and adaptive array antenna. In switched beam antenna, a finite number of fixed predefined patterns. Actually, it has a fixed beams. Adaptive array antenna has infinite number of patterns, which is scenario based. We can adjust it in a real time basis. In switched beam, this system form multiple fixed beams with heightened sensitivity in particular directions. Switched beam systems have several available fixed beam patterns. A decision is made in which beam to access. Whenever there is a particular location, more number of users, that particular beam will be accessed at any given point of time based upon the requirement of system. As the mobile unit moves throughout the cell, the switched beam system detects the signal strength and continuously switches the beam as necessary. This is the figure of switched beam system, which has multiple arrays, and it used to detect the particular beam where more number of users in that beam. It improves the gain on the particular beam. So it subdivides sector into many narrow beams. Then each beam is considered as individual sectors. Several users or group of users. So this is a block diagram of switched beam user where it has a phase shifting network, RF switch, detector and control logic. The phase shifting network which forms multiple beam looking in certain direction. The RF switch activates the right beam in the desired direction. The selection of right beam is made by control logic, which is governed by algorithm. So direction of arrival algorithm is included for signal received from the user. The algorithm scans all the beams and select one strongest received signal. The overall goal of the switched beam system is to increase the gain according to the location of user. In adaptive array antennas, the systems are really smart because they are able to dynamically react according to the changing RF environment. They can direct the main beam towards signal of interest. So now there is a more population, that particular area we can activate the beam forming while suppressing the antenna pattern in direction of interferers. So there will be some interference will be avoided in this adaptive array antennas. It can customize an appropriate radiation pattern for each individual users, dynamically adjusting an antenna pattern to enhance reception while minimizing or fully rejecting the interference. So this provides optimal gain while simultaneously identifying, tracking and minimizing interfering signals. So here the concept uses space division multiple axis. So beams are sliced to keep different users in different beams at the same frequency, which allow frequency reuse where a neighbor beam may not use the same frequency. Different beams you are activating at different directions. This technology achieves superior level of interference of suppression and reduced RF pollution. So this is a example for the space division multiple axis where we can activate the particular beam where the users used to communicate with each other. Evolutionary path towards increasing the capacity of cellular system. We can also increase the capacity of the cellular system. The difference between the switched beam and adaptive array. So integration, when come to in the criteria integration, easy to implement in switched beam and low cost. In adaptive array, transceiver is highly complex and high cost. So range and coverage, switched beam more coverage compared to conventional systems, less coverage compared to adaptive arrays. In adaptive arrays, more coverage compared to switched beam systems. Interference rejection, difficulty in distinguishing between desired signal and interferer. Adaptive array focusing is narrower. So advantages of smart antennas: enhanced coverage through range extension, fully controllable by software, so less manual operations, reduction in transmitter power, then reducing the co-channel, sub-channel interference, provide high security, improve system capacity and highly compatible, and we can use the techniques of TDMA, FDMA and CDMA. So drawbacks of smart antennas are the transceiver design is more complex than the traditional system and it is highly expensive. The applications are cellular and wireless networks, satellite systems. So the technology uses MIMO, multiple input, multiple output, multiple input, single output, single input, multiple output. The applications are Wi-Fi systems, cellular system, WiMAX, radar and others. The regions applications used in North America, Europe, Asia, Pacific, Middle East, Africa, South America. And so finally, the smart antennas or intelligent antenna system that varies vastly improve the efficiency of wireless transmission. Smart antenna can achieve high transmission data rate and coverage area by effectively reducing multipath and co-channel interference. The smart antenna system are software controllable, remotely configurable, where we can control the direction of antennas, that particular beam, promising technology to resolve the traffic capacity. Thank you.